Hi to everyone. In this video, let us discuss Lewis acid base theory. So, what is Lewis acid base theory? Let us see here. So, now if you observe that which one Arrhenius theory and Bronsted-Lowry theory, there are some defects are there. So in Bronsted theory, what are the defects means here? Bronsted theory could not explain acidic nature of some compounds like BCl3, BF3, AlCl3, etc. And another thing here, the donation of proton or acceptance of proton should take place only in the presence of another substance. So that is also one of the defects of Bronsted-Lowry theory. And it could not explain basic nature of some compounds also. Like which one BaO, CaO, like that. So to sort out those defects, again another theory was proposed here. What is that theory? Lewis acid base theory. So according to Lewis acid base theory, let us see what is the definition of an acid. So acid means here the substance which can accept electron pair from other substances and form dative bond. That means coordinate covalent bond. That substance is called an acid. That means electron pair acceptor is known as which one? An acid. And similarly, what is the meaning of a base or definition of a base? So as per Lewis acid base theory, the substance which donate electron pair to other substances and form dative bond, that substance is called which one? Lewis base. That means here electron pair donor is known as which one? Lewis base. Okay, like this, as acid and base both are defined with respect to electron pair, this theory is also called electronic theory. And we know that Bronsted theory known as protonic theory, here Lewis acid base theory known as electronic theory. Now let us see what are the types of acids. What are the types of Lewis acids? So different types of Lewis acids are there. Now what are the different type of Lewis acids? Let us see here. So what is the first one here? First one is all simple cations. All simple cations come under which one? Lewis acids. That means transition metal ions and other cations also come under Lewis acids. Examples here. What are the transition metal ions examples? Fe plus 2, Fe plus 3, like that. Here you can consider any that Mn plus 3, like that. And H plus also come under which one? Lewis acid only. So all simple cations, that means transition metal cations and other cations also. Other cations means Mg plus 2, Al plus 3, like that also. All simple cations act as Lewis acids by accepting lone pair of electrons. And come to the second example of Lewis acids here. What is the second example here? What is that means here? Molecules with incomplete octet configuration. Molecules which are having incomplete octet configuration. So what are the examples for that? Means BF3, BCl3, AlCl3, like that. See here, BF3 means around boron 3 covalent bonds are there, and 3 bonds means the total number of electrons around boron 6. That means it is not having octet configuration. So by accepting lone pair of electrons, now BF3 get into octet configuration and act as which one? Lewis acid. So this is the this is the second example of which one, that Lewis acid. And third example is here. What are the third type means here? Atoms having sextet configuration. That means 6 electrons in outer shell. That means example here oxygen, sulfur. Oxygen as belongs to 6th A group element. Its configuration NS2NP4. That means sextet configuration means 6 electrons present in valence shell. By accepting lone pair, these can get into octet configuration and act as Lewis acids. So this is the third example for types of Lewis acids. And come to the fourth example here. What is that fourth example means? Molecules which are having vacant d orbitals. Those also can accept electron pair and act as Lewis acids. Even though those are having octet configuration, but due to the presence of lone, that means vacant orbitals, they accept lone pair of electrons and expand their octet configuration. By that, they act as which one? Lewis acids. So example here, SiCl4, SiFO4, like that. Okay, then fifth type is here, molecules having multiple bonds in between dissimilar electronegative atoms. Molecules with multiple bonds in between dissimilar electronegative atoms. So here carbon and oxygen differ in their electronegativity values. Now in between them a double bond is there. So such type of compounds act as which one? Lewis acids by accepting lone pair of electrons. So like this, these are the different type of which one means Lewis acids by accepting lone pair of electrons. All these can act as which one? Lewis acids. Now let us go for types of Lewis bases. So let us see what are the types of Lewis bases. Lewis base means it has to which one accept an electron pair. Sorry, it has to donate an electron pair and form which one? Dative bond. Which accept lone pair, that is known as Lewis acid. Which donate lone pair, that act as Lewis base. So now Lewis base means it should donate a lone pair of electrons. So now the first type of example, all simple anions. All simple anions means example F minus, Cl minus, Br minus, OH minus, O minus 2, like that. All simple anions by donating lone pair of electrons act as Lewis bases. And the second one is here, molecules with lone pair of electrons. Molecules which contain lone pair of electrons, they can also act as Lewis bases. Example here, NH3, primary amine, secondary amine, tertiary amine, and H2O water, alcohols, ethers, etc. So one thing we have to remember here, the molecules which containing nitrogen and oxygen, they act as Lewis bases, but condition is they should have single bonds only. if multiple bonds are present, even though nitrogen and oxygen atoms are present, that act as Lewis acid but not act as Lewis base. Example, NO2. In NO2, both nitrogen and oxygen are present, but due to the presence of multiple bond in between dissimilar electronegative atoms, it falls under Lewis acid, does not come under Lewis bases. So the molecules which are having either nitrogen or oxygen, but that should be saturated compound, then that should act as which one? Lewis base. If multiple bond is there, that come under which one? Lewis acid. Okay, then another third type is here, molecules having multiple bonds in between similar electronegative atoms. That means here ethylene, in between two carbon atoms multiple bond is there. Here acetylene, in between two carbon atoms multiple bond is there. And benzene, in that also in between carbon atoms we can see double bond. So now here by donating pi bond, that means pi electron pair, by donating pi bond, these molecules act as which one? Lewis bases. So these are the different type of Lewis bases. Okay, now some other questions related to these three theories. What are the questions related to these three theories here? First question, all Arrhenius acids are Bronsted acids. Is it true or false? Yes, it is true, because with a common sense we can give the answer. What is that? After Arrhenius theory, Bronsted theory was proposed. That indicates what here? To resolve the defects in Arrhenius theory, Bronsted proposed a new theory. That means in Bronsted theory, all Arrhenius acids also should be covered. That means here all Arrhenius acids come under which one? Bronsted acids. But which are not covered in Arrhenius theory also present in Bronsted theory. That means all Bronsted acids are not Arrhenius acids. That's it. And similarly, all Bronsted acids come under Lewis acids, but all Lewis acids are not Bronsted acids. So one example here, what is that? BCl3, it is acting as Lewis acid. That means Lewis theory can explain acidic nature of BCl3. But as per Bronsted theory, an acid means it has to donate a proton. But where is the proton here? No, there is no proton. That means it is a Lewis acid but not Bronsted acid. So like that, all Lewis acids are not Bronsted acids. But all Bronsted acids come under which one? Lewis acids. So see one example. HCl is come under which one? Bronsted acid. By donating proton, this can act as which one? Lewis acid. Sorry, Bronsted acid. But in this, H plus ion is there. H plus ion is nothing but which one? Due to the presence of vacant orbital, it can accept lone pair of electron. That means HCl means nothing but H plus come under both Bronsted acid and Lewis acid. So like that, all Bronsted acids are Lewis acids, but all Lewis acids are not Bronsted acids. This is applicable to bases also. All Arrhenius bases are Bronsted bases, but all Bronsted bases are not Arrhenius bases. And similarly, all Bronsted bases are Lewis bases, but all Lewis bases are not Bronsted bases. So this is regarding which one, Lewis acid base theory and comparison with the three theories. Okay, in our next video, let us go for ionic product of water.